Yeah. All right. Good morning, Richard. Okay. So it's only you, Richard. I feel like we should be more. Let's just be another person. So let's see. Hello. Hi guys. Hello. So this is what is going to happen. Instead of just waiting for everyone, since the class is actually being recorded, I don't plan on wasting time today. There's a lot that we have to do within the 40, 30 to 40 minutes that we have. So I'll just start immediately. Any um any new participants that I see coming now, I'll admit them. But for now, let's begin with the class. And Bendy, right? Please mute your mic so it doesn't interrupt what we are what it doesn't interrupt the session. All right, thank you. So in the last class we talked about okay, in the last class we talked about data modeling and machine learning. And what we try to do is we try to define what data modeling is all about. It being the process of creating machine learning models that are capable of predicting labels. Will do. Well, um, as I was saying, data modeling being the process of creating machine learning models that are capable of predicting labels from futures, tuning them for business needs and validating it on old out data. And I try to emphasize on what this concept is really all about. It's all about trying to create models that can understand the real world problem, not just mimic it now, but could find patterns within the inputs. Because we all know that machine learning is all about this input output things where the data is the input and we try to get the results from the given data. So what we have bent around now is the patterns. So why do we model data? We also talked about it. It's we model data because um we attempt to create a bridge, that is a pipeline now between the data sets for the machine learning model. So we as the machine learning engineers now we're actually the term here is the pipeline. We're actually the middleware that connects the data sets, the future engineering, and all of this stuff to ensure that okay, the data meets or matches the output that we need to get. So, other than why we do this thing, why we model data, we talked about the checklist that we'll be making use of. And this is one thing I didn't really do properly yesterday. That is properly guiding you guys through the checklist. Now, in the checklist, the goal is that the checklist helps you to maintain the order while you are trying to analyze your data and while you are trying to create a model for the data. So you don't just, if you don't follow a particular process, everything will be wrong and the likes. And if you, I believe all of you have gone through the notes at least to a degree, you realize that following the process help you not just organize the codes now, but it also help you to be able to create functions that help you manage the changing of the code as time goes on. So let's say you have a data now, you have you have the data set and you splitted it into your training set, your validation set, and your testing set. With the three sets now in place, you'll be able to make use of a function after training, after doing your brief analysis to understand what needs to be cleaned, what needs to be adjusted, and all of this stuff. You'll be able to create a pure function now that will automatically do this. So when you have new data, the new data, making use of that function will automatically clean itself up. And that's the whole process of the data cleaning, which is why we created the separate notebook now. One of the things we were trying to do then was we tried to talk about the data that were missing, and we after analyzing the data set, the Big Mart sale prediction data set, we realized that the item weight was missing. That's this column here, and then the outlet size, this column here, was also missing. And we filled these missing columns by filling because the item weight now is a continuous column, we filled it with the media and the mean value now of the general item weight. So this particular space was filled with the mean value seen here and the mean value seen here and here. And we did it with this particular code here. The fill now, and we fill now with the Big Mart sales item weight.me. That's what this particular code does. Takes the mean of the code, the mean value of the item weight, and it fills the empty cells now with the mean value of the item weight. Then for the outlet size, being a categorical variable, we decided to do something different because a categorical variable is called so due to the fact that it is not continuous in nature, it is categorical in nature, just as you can see here, medium, small, medium, high, all of these are categories. So what we did, in order not to waste so much time trying to fill trying to predict or guess what the data might be, we just made use of a forward field, which would take the value before the empty cell and place it directly after the empty, directly in the empty cell. So medium, this empty cell will be filled with medium. It does this then, say small, high, small. That is what it does. So that's for the forward filling. Then after doing that, we realize that, okay, our data set is now complete. Now, upon this realization, we have a complete data set of about 8,523 data points now. I think that's the official term for it. I think you could call it rows, call it data points. I just prefer calling it data points. Like that. So we have 8,523 data points. And someone asked a very valuable question. He said, okay, because we know that these values are kind of guessed, they are improper, and they most likely are going to be wrong. In fact, they are most likely wrong, but maybe not all of them for the outlet size, which we provided forward filling. Some will be right, some will be wrong, and like that. What we why the person asked, why didn't we just drop it? Now the issue with dropping a column, which I explained in the format class, is that when you drop it, you reduce the data to a reasonable degree. Especially when we started, you realize that the item weight, for instance, was missing about 1,000 actually above for 1,000 data points, and this was missing about 2,000 data points. And now this is about 3,000 data points, and they won't always cross-sect with each other. And what I mean by that is that, okay, where the item weight is missing doesn't mean that the size and outlet size will also be missing. And this can be a real issue if you are and you drop the listing, because dropping the columns, you just go ahead and say, okay, once a particular row is missing the item weight or the outlet size, let's drop it, and it will reduce the data set format. That's 8,523 to something relatively smaller. And when we work with data, we try to the goal of creating a data model now is to work with as much data as possible. So we try to find means to fill those data points that will be as accurate as possible, if not um, if not totally accurate, but something that will get to a reasonable degree that doesn't that doesn't that doesn't what's the word I'm looking for now? That doesn't exclude the goal, yeah. Something that does not contradict the goal. Yeah, that's the word. Something that doesn't contradict the goal. So in this particular session, what we'll be doing is that we'll be, and maybe I should have asked, I hope everyone can hear me. So it doesn't look like I'm talking to myself. So yeah.
We can hear you.
Okay. So as I was saying, the goal for today now is we want to look at um, two major things. That will be the future engineering. Okay, actually three: the data cleaning, the future selection, and the future. Okay, no, data cleaning, future engineering, and future scaling. Yeah, those are the three things. We already started with the data cleaning yesterday. As I said, I was in so much of a hurry to meet the time and all of this stuff. So I kind of like okay. I'll answer that question in a bit. So as I was saying, we were I was in a hurry to answer to complete everything on time. So I just stopped everything in a way. So what we'll be doing in this class is we'll just take everything one at a time. We'll start with the data cleaning, which we've already started with. We'll complete it, then we'll talk about the future engineering, which is next, because I talked about why we stick to future selection, and I'll still to it, and then we'll talk about future scaling. So concerning the question, why do we feel that the forward field is better for this? That question that was asked by Louis. The reason why we make use of forward filling is not necessarily because it's the best. As I said, the reason why chose, the reason why I chose this method is because it is faster and it just helps us to move forward. It's not actually the best. In many cases, it's even one of the worst. The reason being that there's no reason why this should be high. We don't have any real motive why they should be high. One of the a better way to have handled this might have been to drop the outlet size. But as I said, we also want to know the effects of the outlet size when we make predictions, at the end. So it is important for us to still leave it. There's what you could do if, say, an advanced method you could do is if, say, you wanted to maintain the integrity of the outlet size, you could drop empty cells of you could you could drop the empty cells in between. Okay, so you could drop the empty cells of the outlet size. So you could, by doing so, you maintain the integrity of this column without actually messing up your data. So quite all right, you'll still be losing about 2,000 data sets, but you will know that, okay, what I'm working with now is still more genuine. I don't know if you get my point. You know, it's still more genuine. Why did I not fit it with the mode? Actually, that's just another solution. You could fit it with the mode. And okay, wait, I think you are talking about the category continuous data now. You're talking about the continuous data. The mean is actually the most precise value, because you know the mean
I
is
mean,
like
for the outlet size, why did you not fill it with the mode? For the outlet size.
defining mode here is hello.
I said, why did you not fill it with the mode for the outlet size?
Yeah, I know. I got your question, but I said you should define mode, because what I understand by mode might be different from what you mean by the mode. So that's why I'm asking for you to define the mode.
The mode is the most frequent one among the medium, high, and the small, the most frequent one.
Okay, that's what I was trying to say before. You could make use of that too, but the reason why I would encourage making use of the mode, most especially, is, as you said, is the most frequent. It will just populate the data set, okay, with the most popular listing, the most popular of the, or the most common of the different categories of the outlet size. That could be useful based on your understanding of the data set. But right now, what we understand of the data set is very little to nothing. So I don't know if that's attempts to answer your question in a bit.
Yes, it did. Thank you.
So there's one other thing that we realized from this data, and that was the item facts content. And what we realized was that not all of it is low fat and regular. There are actually some that are lowercase. You know that this low fat is a common case with a capital L and capital S, but the low fat here is all lowercase. There's one issue that we realized with this particular feature, then this LF, which also stands for low fat, and then the REG for regular listing. One of the ways we're able to find that out was when we asked for the maths. What is the name of the feature for item facts content? Which naming convention is actually no? So the item item facts, then content, but the unique. So when we asked for the unique now, it gave us rather the values that are unique to it. So the low fat, the regular, the low fat, which is the lower case here, the LF, which is for low fat, form of abbreviation, and then there's the reg for regular. One way we could fix this directly with pandas is making use of the replace keyword. So I just copy this from here, and then come down here and say the replace. So what do we want to replace what with? So you often make use of a dictionary to do this, and you say the low fat. We want to replace low fat now, that is the lowercase fat. Low fat with I just feel this particular form of low fat is more. I also want to replace the capital L. The same keyword, low fat. Very, very good. So I like to copy and paste. Then with the reg, which is for the regular now, change it to regular. So if we were to do this now, I won't actually make the change, just like print it all out, which is the code to show us that okay, this particular thing. But what to do is making use of the in place now. We are trying to say make these changes in place. That is, make these changes that way. that we just did now with the replace method, make it directly in the make it directly in the data frame. That is the pandas data frame. This is our data set now. So that's the data set in place report to, but I'm very sure you guys are already familiar with most of this. Another way to create it to like say it's control C, this equals this, and that will quickly set it up. But you can't do that now with the increase because we just set the whole filter column to now. So with that, we have been able to trigger that change in the data set. And if we were to look at our data now, that's the Big Mart sales. Actually, we won't see the changes here. Not that we will see it here because this is the old data set. But I think you guys shall get my point. To be able to make the change to the low, the item facts content, making it to be just to now. The way we could do that now to see whether the changes have been made is to say this let's change it to the item content and so we see that there are only two values here now, which is the low part and the regular. So that's all for the data cleaning process of the data sets. And then next is supposed to be the future selection from the from our that we are following. And that has to do with dropping the future columns that are irrelevant or little value to the data set. Now, as I was saying before, the reason why we don't proceed to say, okay, we'll pick this one, this future column, I'll pick this one, is because we really don't know the importance of any of the columns. So we'll just keep this particular section for now. It is something that can be addressed later after making use of the futures to address the model. And I guess, okay, I will add it to the assignment and I'll post it to the group. One thing you guys could do is, okay, you guys should try eliminating this particular space now, reducing the data set to, which I believe will reduce the data set to something of about 5,000, maybe 6,000 should be more. Reduce the data set and try still making use of those change to see if you can get the future columns that are essential to the data set. Okay, I'm really sorry about that. As I said, one thing I realized is that the recording, like after the class, is always much clearer. So I'll try to be as precise in the during the lectures, so that it's something that whenever you are done with this class, you could revisit the lecture videos. And also like something that Abdul Ghani said on the group yesterday. The reason why I made this notebook like this is not because I actually like writing notes, not because I actually like writing notes, but I know that I won't actually be able to teach you guys everything you need. It's not that I don't plan on, but I won't really be able to give you guys the depth of what we have to expect from this class. So I did the notebook in such a way that even though if I'm not able to meet all of my aims for the data modeling class, you guys can always push further. You guys can always learn on your own. So the notebook was created in an attempt to build for you to learn at your own pace. So it's a self-paced something. I will only attempt to educate you guys as much as I can when it comes to the data modeling stats and when we start doing the advanced stuff like the column transformer, the pipelines, and the like. But for now, you guys should just stand here with me, and if you can't really get me, during the end of the listing, the video should be clear. So most of what I said will be extremely clear. So now that we are done with the future selection, we'll move straight to the next point, which is what is it again? Future engineering. Yeah, that's the future engineering. And what this is all about, as I said, it has to do with manipulating the filters to meet the requirements of the model, which means converting all categorical columns to numerical values that does not you convert them to numerical value um, that does not devalue its meaning. Yeah, I think that is a good word. That does not devalue its meaning in the sense that, okay, if there were values like this now, values like the I, medium, small, the I will have a value that does not devalue it in the sense that we know that I is supposed to be greater than small, even if it was to be converted to a numeric term. So saying I is a value 3 and small is a value 1, while medium is a value 2 will be appropriate in a classification term because the values now are representing the order in which they are which is what brought us into the concept of the label encoders, the ordinal encoders, and the one-hot encoders. I described this to the best of my ability yesterday, and one thing. Okay, the truth is we haven't actually done any future engineering. That is what we just want to do. Like yesterday, I was trying to explain the concept behind it and take you guys into the label encoders and the rest before the video before the time I went off, and it wasn't enough time to see the class. So and it was already late, so I said I'll just continue today. That's what I'm about to do now. So when I believe yesterday you guys paid attention, we talked about the label encoders, and I'll still share the video link to the group right after this class, so you guys could catch up if you missed it. But as I said, there's a general rule of thumb we make use of for this encoding, and that's whenever you want to encode with a one-hot encoder, they try not to encode a value that has more than 3 categorical variables. So something like this now, I, medium, and small, you can make use of a one-hot encoder. Even though we expand the data set a bit, but it's still appropriate. The same thing with this type 3, type 2, type 1. It's the same thing. It's still appropriate, it should work well. But you can't make use of one-hot encoding for values that are extremely large, as we pointed out in this particular that is the item identifier, where we talked about it having about exactly 1,559 elements. Let me just see that concept. It has 1,159 elements. Now, if you said you wanted to apply this to the encoding, you have a very large data set, and your machine learning model will take a lot of time to process. So there are rules of thumb to make use of that. Now, the rule of thumb is whenever you want to make use of one-hot encoding, you ensure that it's a small set of values, like between 2 and 3, not between 2 or 3. Then you make use of ordinal encoding for values that have order, and you make use of label encoding for the rest. That is just the general rule of thumb. And when we went into the notebook, you realize that I showed you guys simpler ways now to apply this form of encoding to the data. And that has to do with, like, instead of making use of label encoders directly, you try your best to avoid the use of it. You always do something simpler that saves time and the like. But for this particular tutorial video, we've been making use of the label encoders, making use of the ordinal encoders. And I'll just give you guys the feel of how the one-hot encoder looks like, so that everyone gets it. So the encoders now, the 3 of them, both ordinal, label, and one-hot encoding, they are all part of the scikit-learn framework for the pre-processing. That's scikit-learn.pre. If they say import, put it as the label encoder.
Hello, please, I have a question.
All right, I'm listening.
Okay, if you have a data set that has like 16 unique values, you cannot use one hot encoding. Which of the encoding can you use?
If you have
Like
a
16
data
unique values.
that has
16 unique values
16
for
unique
a
values
column.
for a column.
For
Okay.
a column, yes. Like
Okay.
item type now has 16 unique values. Can you use one encoding?
No, you can actually, but it is not recommended because when you make use of one hot encoding, it will expand the data rows, the data column now by 16, which will kind of like further complicate the data sets. Oh boy.
Okay. So label encoding is better.
Label encoding is better for that task. Except there's an order there, then you have to explicitly state the order, making use of ordinary encoding.
Okay.
Yeah, all right. I'll just import the tree of the, what did I say? Oh, yeah. Okay. Label encoder, the ordinary encoder. So I'll just quickly show you guys how the ordinary encoder works. Since we'll be making use of the label encoder. We made use of the label encoder rather. Yeah. All right. And I listed the categorical variables that are present on this site, which are this particular categorical variable. So I'll just copy this particular this thing here. The item identifier now is an example of the feature that we'll be making use of the label encoder for. The item fact content. For the item fact content, it actually make use of an ordinal or a one-hot encoder. But in this case, I'll label encoder. Okay. There's actually a huge difference between replacements and making use of the label encoder. The difference is that when you make use of a replace statement, you choose the particular value that you want your values, the elements to represent. But when you make use of a label encoder, the values are chosen for you. But when you make use of ordinary encoding, you list the order in which the value should be chosen for you, and it places a form of hierarchy on those values. I don't know if what I said made sense to you right now, but okay, let me quickly make use of the item facts to show you my point. So for the ordinary encoder, let's just say the item facts content. The item facts content. Okay, let's add an extra encoder so that the variable name is kind of unique. So we say the ordinary encoder. The ordinary encoder, and this is the beautiful thing about the scikit-learn framework. You just have to call the class and it will automatically do everything for you. So the keyword I want you guys to note for every ordinary encoder is the term categories. Now the term categories is stating that okay, let's make use of the documentation. So if auto, it's manually like if you leave it as auto, which is the default now, it just shuffles the list and or it doesn't shuffle per se, but in the order that it meets it when it calls for the unique value, it places the hierarchy on that order, which is kind of similar to what you'd be doing if you were making use of the label encoder. It's kind of similar to what you'd be doing if you were making use of the label encoder. But when you list out the values now, that is making use of the order distinction, which is a list, well, a list of lists rather, a list of a single list, and that they indicated that with the categories I, which means that okay, in this particular list now there should be an other list inside of it. That's this other list. That's this other categories that will be putting here. So it's saying there should be this other list in it, which would take the categories in the order that will be necessary. The order which you feel it should follow. That is the order I will be placing the hierarchy on. So the first one that I feel is will be the low fat, and they be sure to ensure that we don't misspell most of the stuff. of experience of the future. So that's how you create the ordinary encoder, a simple ordinary encoder for item fat content. When you do this now, you make use of the variable name which the value is being stored in, allow the item fat encoder. It's a dot. The dot fit method fits the data. The data it asks its request for the future column now that you wish to encode. And the future column is going to be that's the item, that's not the item, it's the material, yeah, that's this. Then the item fat content, that's this. So, but if you just enter this right now, you have an error. You are coming very late. You have an error because what you are loading into the fit function is the data frame, and it will bring a value error because it's expecting a two-dimensional array, but you got a one-dimensional array instead. And that is because by default it processes the series now, because this particular feature column that we have here is a series, and we can verify that by saying the type. The actual type is a panda dot four dot series. There's a panda series. So the panda series is always processed as the ND array, a one-dimensional ND array. So what we could do is say convert it to a numpy, making it of it to a numpy function. And before I print this out, I just want to like copy this out so we can see what is really happening before and while we fit it into the model. So everyone isn't confused about what is going on behind the scene. So this is what it does. It converts this to an array. All right, it converts it to an array of strings, which is the data type objects. And this is what it displays straight directly in here. But when we do this particular thing, we still get the same error, which is a value error, which is now it's saying that it still got this one-dimensional array, but it needs you to reshape it. Now the concept of reshaping now is that okay, you want it to assume a two-dimensional form. And this, when they talk about two dimensions and numpy, it just has to do with something like this. So it's an array, this particular array, it's an array inside another array. And the way you can do this is by making it of the shape. And when you say the shape, you take one, and one. It does this. So you can see that this particular array is within another array. So that's the whole function. So just cut this. And I'm explicitly stating this out for those that maybe have practiced and you keep getting this error, or you are prone to this kind of error. So you just know how to fix it once and for all. So I just if you do this now, it has created the ordinary encoder. It has fitted the ordinary encoder, which will do the processing for our data set. And what we want to do now is we want to transform it, and we do that by acting for the item contents, item factor, transform. So if we call for this, we transform, and we act for this same thing. I guess the better way to have done it would have been to store it in the variable. So that's one thing. What you like for it? What time we are running out of time, so I can't start. I don't need to run this cell anymore because we've already run it to fix the model. The reason why we ran it cut the value into this variable, I can start it so that we could just transform it and see the output. And this does the actual encoding of the value, which converts low fat to 0 and regular to 1. I can confirm that for me. That from the data set, what we have low fat 0, 0. This kind of so I really don't know how I did this, but one of the ways you could check the values that what represents what saying the item content categories. So we just ask for the category. So we have the low fat, which is the zero calorie, and the regular, which is this thing. So I'll be ending the video here. I'll create another link so we could make use of to continue with what we're doing. We'll talk about the label encoders and one hot encoder.
We can use the same link, sir.